All right, so with that said, having gone through the exam, let me have you sign in for today. Here's the attendance QR code. All right, everybody get that?
It's detecting it, but it's not. The link isn't showing you.
It still says September 27th. Is that okay?
Yeah, it's for today, though. Yeah. Is it going through all right?
I got it.
Okay, great. Let's go over a couple of announcements here. By the way, I don't know if I've mentioned it recently, but these notes are posted on Blackboard. And of course, the video will be posted on YouTube. So if you lose track of the announcements, you can always look at the course schedule. You can look at the notes that are provided as PDF files. You can go back to the lecture recording. But Wednesday's class, so 2 days from today, we won't meet together in person. I'm going to be posting a video on YouTube, and I'll email you the link for that. But instead, during our class time, I'm hoping that you'll take the time to go to the career fair. There's a lot of companies that are going to be there. Most of them in engineering, a lot of computer science. So if you go through the list, more than half the companies on this list are looking to hire engineering people and computer science people. And I think 135 companies are signed up. So I think it's a great opportunity for you to maybe go and make some connections and learn about summer internships. Or a few of these companies will have employment opportunities during the academic year. Or if that's not on your radar, it's never too soon to start thinking about what you want to do after you graduate. So just to give you a bit of an incentive to attend, beside the fact that I'm canceling class to make it easy, if you go to the career fair, I'll give you 1 bonus point on the exam that you just took. If you take a picture of yourself at the career fair and a picture of like 2 business cards or brochures or whatever promotional materials that's kind of like a proof that you actually talked to somebody. So a selfie of yourself at the career fair, so it's obvious to me that you went. Don't take a selfie out on 3rd Avenue or something, because I'll have no idea if you went to the career fair. But the purpose of the photos is so that I know you went to the career fair. And then 2 items of anything that proves that you went there and talked to some people. So it could be like swag that they give out, like pens or a business card or brochure. And if you submit that before Friday at 5, then I'll add 1 additional point to your exam score. Yeah.
When you say submit, are you referring to by email or by Dropbox?
Thanks. Blackboard. Yeah, Blackboard. So I've created what looks like an assignment in Blackboard, and once it's submitted, then I'm going to change it from an assignment category to a nothing category and manually add 1 additional point to everybody's exam grade who did it. So you can find that on Blackboard. And speaking of which, you'll need to go to Blackboard today because I've got a template file that you're going to use for today's in-class exercise. It's a spreadsheet that I just put onto our main class page. So we'll take a look at Blackboard here just to get on the same page with those things. All right, so at the bottom here of just the front page of the course, there's career fair, which is that's where you go to upload your photos. And then today's template file for the in-class exercise is available there as well. So let me open that. I'll have it at the ready for when we get to that point. This is what we'll be doing. Okay, so that's the career fair on Wednesday. There will be a video, a really important video for you to watch on Wednesday's class. The 2 things that'll be on that video, number 1 is another problem practicing external rate of return. So what we're doing today is one of the two most complicated things we'll do all semester, just in terms of like multiple steps. I mean, I don't think it's that complicated, but a lot of students get hung up on it, and so there's extra practice on Wednesday's lecture. And then the other thing I'm going to include in Wednesday's lecture, which will be posted online, is kind of a getting started illustration for the project. So if you've been looking at the project but you don't quite know how to open up Excel and start calculating things, the lecture video for Wednesday's class, I think, will help you to get a little bit of momentum. So just because we don't have our scheduled class meeting on Wednesday, I hope you don't skip that video that I'm going to put on YouTube, because it'll be valuable if you do watch it. Homework 7 is posted now, and it's due next Monday by noon. It's only 5 problems, 2 bond problems, and then 3 that are related to new material that we're going over starting today. And then the project, speaking of, that's due on Friday the 17th. All right, lots of announcements. Yes?
Yeah, so the homework's posted, but it only shows problem 4 or 5. The rest of the problems aren't there.
All right, I'll fix that. Thanks for letting me know. Today we're going to be looking at external rate of return analysis. And I want to tell you about external rate of return analysis by showing you an example of what you couldn't do an analysis on with the IRR. So do you remember last week we talked about IRR? What does the I stand for in IRR? Internal. So what is the assumption on IRR analysis?
If it's like what decides if you take a project or not.
What's that?
Like the assumption that, never mind.
Okay.
All right.
And one more time? Keeps feeding into itself. And so to extend on that, it is like a project's generating money. You have to be able to reinvest that money back into the same project or another project that has the same rate of return. That's the assumption of internal rate of return, is that you're going to reinvest your dividends, or you're going to leave your money in the savings account and it's going to earn interest on top of interest. So sometimes that's true, but it's not true in the case of art investing. So this painting was painted by Leonardo da Vinci, allegedly. There's actually some debate about that, but let's take it at face value that maybe it was painted by Leonardo da Vinci, and it sold in 2017 for $450 million. I believe it was sold to the Crown Prince of Saudi Arabia, but I may be misremembering. I think it was sold to the Crown Prince of Saudi Arabia for $450 million, and in 2005, its last sale before that, it was sold for $1,175, because it was basically one of those stories you hear of an old junky painting in a yard sale that everybody thought was maybe just a reproduction, or they didn't really know where it was from, and it was actually quite badly damaged. So someone bought it, suspected it might be an original. They did all kinds of analysis, and enough experts said, yeah, we think this is a Leonardo da Vinci original, that it jacked up the price. And so this is the most valuable art purchase of all time. There's never been a painting that sold for more than that. But the person who made the money couldn't take that money and reinvest their profits into the same thing, because there's only one. It's a completely unique thing. So they can't take their profits and do it again exactly the same way. They're going to have to take the profits and reinvest them somewhere else. So you wouldn't be able to calculate the internal rate of return of this transaction, because internal rate of return would assume that you're going to take the profits and reinvest them in a project that yields the same outcome a second time. So just to summarize, IRR will allow you to do the initial screening of a project's suitability. You can compare it against the minimum attractive rate of return and either get a yes or a no on whether a project is acceptable. What you shouldn't do, though, remember, is you shouldn't compare and select which project to choose based on IRR alone. And we'll emphasize that point again in the future, but what I said last time was the reason is different projects sometimes have different initial costs, and just picking whichever one has the highest rate of return won't necessarily give you the project that's the most profitable. So that's why you use IRR screening for acceptability, but not for picking which alternative to select. So internal rate of return assumes that the cash flows are reinvested into the same project or another one that has the same return. When that's not true, we instead have to use external rate of return analysis. And this is far more common. A lot of the investments that you'll make or that companies will make, you'll buy new equipment, it'll generate some additional revenue, but there's no need to buy that same equipment again. So you have to take the revenue that was generated and put it on some other project or into some other kind of investment. So external rate of return is far more common when we're trying to really understand how profitable certain projects are. So the rare painting is one example, but just about anything where you have to buy something else with the profits should have external rate of return used as the analysis. So the method is a little bit tricky. Not that tricky, but a little bit tricky. So let me tell you the method. The method is there's some external reinvestment rate. I sub I is the variable for that. That is how much money, well, it's the rate of return that you're going to make on the funds that are generated. So like the person who sold this painting, they took the $450 million and they did something with that. Maybe they bought bonds. If they bought bonds, then whatever the bond yield is, that's their external reinvestment rate. Or if you opened an ice cream store and you bought the scoops, you bought the ingredients, you refurbished the space, and now you've got your profits coming in, you don't need to do all those initial things over again because you've already got the store set up. So you take your profits and you put it into a mutual fund or maybe a savings account or something. Whatever you put your money into, whatever rate that it earns, that's the external reinvestment rate. So I sub I is given. So it's the rate that the cash flows that are generated of the project can be reinvested. It's where you put the money and the rate that it earns. So the approach to calculate the overall external rate of return is all of the outflows for the project, meaning your expenses, get discounted to times zero using this known I sub I rate. So in other words, calculate the present value of the outflows, discounting all the future amounts to the present using the given external reinvestment rate. All of the inflows that are generated by the project get compounded to the end of the cash flow diagram. So the end of the study period, the end of the equipment's useful life, whatever defines the end of the project, compound all of the inflows to the end of the project at this given interest rate, I sub I. So in other words, you found the future worth of the inflows. And now the third step requires iteration, goal seek. Remember how we've used Excel's goal seek a couple of times? What you're going to do with Excel now is you're going to discount the sum of the future value of the inflows to the present, and you're trying to look for what is the interest rate that makes the inflows and the outflows equal to each other. So I've got a template that kind of illustrates and implies what this process is. Any questions so far? Okay. So here's a graphical summary of the steps. So graphically, you've got some cash flow diagram. And what you do is you take all of the outflows to the present. So this big line that's pointing down just means, you took these amounts to the present. Now this is very important. There's going to be some years that has both inflows and outflows. Don't take this outflow to the present. You just find the net effect in each year. So the net effect of this inflow and outflow is going to be mostly inflow. So you'd find the net value for that year, and you'd compound the inflow to the future, but you wouldn't do anything with this outflow because it's the net amounts that apply. So this arrow would be the effect of this outflow and that one, but then that outflow is just going to reduce the amount of the inflow in that year, and it's all compounded to the future at I sub I, the external reinvestment rate. So now you've got two lump sum amounts, and this is just a note reminding you that you just take the net amount if you've got both inflows and outflows in the same year. And then the last step is you're taking this lump sum amount that's at the future and you discount it to the present, and you want to find out what is the interest rate, what is the external rate of return that makes it so that the magnitude of the present value of the inflows is equal to the magnitude of the present value of the outflows. It's pretty abstract, but with the template and the practice problem we've got, I think it will be very clear to you. So any questions on the fundamental idea here? So the external rate of return, we have to start with a guess. And then we're going to keep changing the interest rate around using goal-seek until it converges on a solution. And it'll automatically stop iterating, Excel will, once we found what amount makes it so that the inflows and the outflows at the present are equal. Here's just another way of looking at it if you want to think about it in terms of a formula. Now this really does make it seem complicated, maybe more than it needs to be, but let me talk you through what it's saying. It's saying add up all of the expenses, and the expenses, remember, those are the outflows. So the outflows should be at the present. So you find the present value of all of those future outflows, and you're discounting those individual amounts at the external reinvestment rate. The revenues are all being sent to the future, so they're compounded to the future at the external reinvestment rate, and then you use the external rate of return to make them equal to each other. All right, so here's the in-class exercise cash flow diagram that we're going to work with. And I printed out papers for you today, but unfortunately I left them in my office. I brought the exams, forgot the in-class exercise, but you've got the template file, which is the main thing that you need. So let's look at this template file. Let me paste the cash flow diagram into Excel, and let's talk through this together. Okay, so we've got a column that's years, and then this is the reverse time column. Remember that the technique says that we need to find what is the sum of the sum of the inflows in the future. So we want to find out in year 13. So where it says years until blank, 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 let's delete that. It's years until year 13 that we want to find. And the external reinvestment rate in this problem is 5.5%. So the given external reinvestment rate, I sub I, 5.5%. So put that in here, 0.055. Okay, so let's fill in the reverse time column that we're going to use when calculating the future values. Equals 13 minus whatever year we're in. So then if you drag that formula down, it will be what we use when calculating the future value. Okay, now there's a column where we put in the net outflows and a column where we put the net inflows. So for example, times 0 is a net outflow. So I'll put 11,500. Now it says outflow, so it already knows that that's minus. So I'm not going to put the minus in the cell because by definition, outflow means money that's going away from you. So we don't have to put the minus sign in as well. So there's that 11,500. Now what about year 5? Should I put 4,000 here?
No.
Good, you're right. I shouldn't. The net amount. So the net amount is going to be taken into account here for the inflows. So I don't need to put anything into year 5, and I shouldn't. So year 9 is 5,400. What about year 11? Should I put 1,100? No, because that's going to go into the inflows. It's going to be accounted for there. Okay, so I can just leave that as is. I could put in zeros, but I don't need to. If nothing's there, Excel knows it's 0. Okay, what about the net inflow? So 6,500, 6,500. Okay, year 5. Well, let's say I'm bad at doing math in my mind, which is true. Equals 6,500 minus 4,000. I could probably do that one, but Excel will do it for you. You know, if you've got both an inflow and an outflow, maybe just calculate it so that there's no mistakes. For year 6, back to 6,500. Year 7, 92,00. Year 8, nothing. Year 9, nothing in terms of the inflows. You can put zeros or you can leave it blank. Year 10 is nothing. Year 11, 7,800 minus 1,100. And then 7,800, 7,800. Hey, wait. The cash flow diagram went all the way to year 18. So why didn't I make year 18 be the end of my study period? Well, the reason why is unless you've got other instructions, you should assume that the end of your study period is the last year that there's some sort of a financial transaction, an inflow or an outflow. So if the problem statement said you have a 15-year study period, then you would say you'd have the cash flow diagram all the way through 15, but this one doesn't. So it's just kind of a distraction, an intentional distraction to make the point that you shouldn't let the number of periods be 18 just because the diagram has 18 on it. And it could have had 20, it could have had 22, but the last year that something happened was year 13. So by default, that is our study period. All right, so I'm putting these zeros in, I guess just out of consistency. I'll put zeros anytime there's nothing happening. So 0. Okay. Does everybody understand what we've done so far? We've broken the inflows and the outflows apart from each other. Now here it's saying find the PV of the net inflow, and in parentheses it's saying discounted I sub I. So we're going to use the given external reinvestment rate. So equals PV. The rate we're using is this given 5.5%. Click on it and then press F4 or manually type in those dollar signs to anchor the cell reference. Comma. Number of periods. What should we use for the PV? Should we use column A or column B? Column A, because it's going to the present. So for example, the amount that's in year 0 needs to move 0 years to get to the present. Okay? Double comma to skip over the payment field and minus of the amount into the field that's designated future value. So 11,500 isn't going to change at all, but that 5,400 changes. If you take 5,400 in year 9 and discount it at 5.5% every year, its present equivalent is 33, 35, and 20 cents. Okay, so down here, let's calculate the sum. So sum of all of these cells above it. Okay. Now we're going to do future value only on the net inflow column. So equals FV. The rate is still the external reinvestment rate that's given. Okay, NPER. What should we use for the number of years to get it into the future? Years until, that's right. So the reverse time column, because we're compounding it into the future. Okay, skip over the payment field with the double comma. Now the amount goes into the present value. So minus of the net inflow goes into the present value field. And now we're going to find out for each of these inflow amounts how much they compound to when you're finding the future value. So like the 6,500 in year 1 is bigger than the 6,500 in year 2 because it's compounding an additional year into the future. So it has a larger effect because it was further away. Again, we'll calculate the total using the sum function. All right, let me pause for a second and just see if anybody has individual. Okay, so the sum of the outflows is 14,835. The sum of the inflows is 95,162. So we were given the external reinvestment rate, but what we want to find is the external rate of return. That's not given. We have to start with a guess. So let's just say, well, maybe it's 1%, 0.01. Okay. If it's 1%, then the last thing we're going to calculate here is the PV of this amount. So what is the present value of the sum of the future values? Here's the sum of the future values, 95,162. So we're going to discount that at the external rate of return and see what it is. So equals PV of, using this external rate of return, and the number of years, that lump sum amount is 13 years in the future. So use 13 for NPER. Skip over the payment field and minus of this 95,162. So if you discount it at 1% per year, the 95,000, which was in year 13, if you take it to year 0 at 1% discounting per year, then it's 83,615. We're looking for these two green cells to be equal. That's our objective in the goal seek, is we want to keep changing the interest rate so that this number is equal to that one. So if I say 2%, it'll get closer. 3%, it gets even closer. What about 5? Getting warmer. 10%, getting warmer. 20%, that's too much. Okay, so the final thing we do is a goal seek. Data, what if analysis, goal seek, and our objective is for this cell to be equal. I'm going to have to type in 14,835 and 20 cents by changing the interest rate. And when I click OK, what it's going to do is it's going to keep changing the external rate of return guess until it achieves convergence, meaning when that target cell is equal to the value that I've typed in, 14,835, then it'll stop. 15.37%. So, conclusion. The external rate of return is 15.37%. External rate of return takes into account both the rate that profits are generated and also the rate that the profits earn when invested elsewhere. So we take this money and we're putting it into an account that yields 5.5%. This is kind of like a weighted average. It's a really sophisticated weighted average that takes into account the time value of money, when the profits are generated, and the rate of return on that external account. Okay, so we've been through this one time. If you didn't get it all the way finished, I really highly recommend you watch today's video. And then Wednesday's class is going to have another example. So then you'll have 2 practices in your pocket that you can use before starting on the homework assignment that's due next week. Question?
Is there a ERR function like there's an IRR function?
No, there's not. Yeah. All right. I'll see you in class on Friday. Wednesday's lecture is recorded.